Welcome to this course on GitHub Advanced Security, where you will learn how to tackle real-world security scenarios as part of your DevSecOps and secure software lifecycle management. My name is Peter Ditender, a lead technical trainer here at Microsoft with a passion for DevOps, or maybe should I say DevSecOps. If you should have any questions when watching this video, don't hesitate reaching out through email or LinkedIn to get your questions answered. This is the second module in a 5-module series, where we'll leave the introductory level from the first module behind us and jumping straight into several GitHub best practices on how to manage sensitive data and integrate security policies in your repositories. In this module, you'll familiarize yourself with GitHub's basic security tools, which prepare repositories for secure development and industry standard response to threats. You'll also act as a repository or maybe even organization administrator to tailor documents and settings to your organization's needs. Throughout this module, you'll learn how to create and manipulate security policies and settings to ensure safe and easy collaboration for a new repository. You'll also learn how to create documentation that details security guidelines, as well as useful information for other collaborators. Next, you're going to learn how to set permissions, as well as integrating other security rules. I'm going to show you how to manage repository rule sets. You're going to learn how to automate processes, preventing security risks. And then last, I'm also covering how to export audit log records and Git events. A repository or organization or enterprise security policies are the practices and settings that maintain the integrity of users' data and systems. A security policy defines what it means for a system, an organization, or another entity to be secure, and also limiting permissions to support that definition. Now, what does it actually mean for you and your GitHub ecosystem? When you create security policies, you're telling collaborators how to work in ways that maintain code health. Security policies also provide resources for responding to, for example, security vulnerabilities, as well as limiting collaborators' access. As a GitHub admin or a repo administrator, you can set some security policies individually at each level of your control, which again can be a repo, an organization, or even the full enterprise. For instance, you can give individual organization owners permission to allow collaborator write access or any other kind of access for that matter, or as the admin, you can require all organizations within your GitHub enterprise to allow only a certain kind of access. Documentation and security settings basically serve 3 broad purposes. First of all, standardization. Security policies ensure that everyone on your project responds in the same way to common issues, making it super easy to know what is happening and why it's happening. Second, they help with compliance. The countries, regions, or business industry in which you plan to develop and probably publish your projects might require that you follow industry standard practices for coding, but also recording security events. Or maybe you have certain data compliance and governance regulations to keep into account for your software codebase. And then last, these settings assist in preventing critical failure. Most importantly, solid policies defend against events that threaten continued development, like publishing secrets or maybe intellectual property. As an administrator working on the team responsible for setting up a new repository in GitHub, the first thing you should do is create certain default community-held files. GitHub assigns special significance to those files that makes it easy for any collaborator to find them. In this section, you'll learn about the characteristics of those key files. If you ever contributed to, or maybe even looked at an open source project, you'll quickly be able to tell if that project has a healthy contribution level. This is directly related to how closely the project follows recommended community standards, which include a list of recommended documentation files. And yes, I'm talking about the readme.markdown, code of conduct markdown, or even the contributing markdown file. Just like an open source project with documentation on how to best contribute, your repository, your organization, your enterprise immediately benefits from a list of recommended documentation on your specific security policies. These files record information about security preparation, key contacts, and the project background. They tell collaborators and other users what measures you have taken to protect the repos, what to do or who to reach out to in the event of a security issue, as well as providing guidelines for contributing to the project. Now, before we go further, you should know that you can configure security settings at the organization and enterprise level. These choices are also part of organization policies and enterprise policies. Choosing settings for individual organizations or for the entire enterprise goes hand in hand with creating the proper documentation, as we discussed previously. Here is an example of a basic security setting you could change at the organization level or for the whole enterprise. You might choose to set base permissions for all members of one organization working in any given repository owned by that organization. With this setting, one organization's members could have read access to repositories, while other organization members could have write access. Alternately, you could also apply that setting to every organization which is covered by the enterprise plan. As should be clear by now, settings that enterprise administrators enforce cascading down to all organizations covered by the GitHub Enterprise Plan. While at the same time, settings not covered by enterprise administrators are free to be customized by your organization admins. Only GitHub Enterprise admins and organization owners can configure those organization security settings. Now, what makes these security settings especially powerful is the mix of automation as well as manual controls. Tools like Dependabot can automatically update dependencies and flag vulnerabilities, reducing the manual work needed to keep things secure. Where at the same time, features like security advisories or documentation, those require more hands-on attention, but they are crucial for communicating risks and responses. If you wonder what the real benefit is, administrators can standardize user capabilities, quickly restricting or expanding access whenever needed, and automating routine security tasks. Overall, making it easier to protect your codebase and again responding effectively to any threats that might pop up. Next, let's talk a bit more about the security advisories. Vulnerability disclosure is an area where collaboration between vulnerability reporters, such as a security researcher, and project maintainers is quite important. Both parties need to work together from the moment a potential harmful security vulnerability is found, right until the vulnerability is disclosed to the world, ideally with a patch available. Typically, when someone lets a maintainer know privately about a security vulnerability, the maintainer develops a fix, validates it, and then notifies the users of the project or the individual package. Repository security advisories allow maintainers of public repositories to privately discuss and fix a security vulnerability within that project. After collaborating on a fix, repository maintainers will then publish the security advisory to publicly disclose the security vulnerability within the project community. By publishing security advisories, repository maintainers make it easier for their community to update package dependencies and do more research, finding the impact of the security vulnerabilities. Now, with repository security advisories, you can, first of all, create a draft security advisory. and use the draft to privately discuss the impact of that vulnerability to the project to make sure everyone clearly understands the security issue. From there, you can continue a private collaboration to fix the vulnerability in a temporary private fork. And then last, in step 3, you're going to publish the security advisory to alert and inform your community of the vulnerability once a patch has been released. As an administrator responsible for managing security policies and settings within your GitHub environment, you might face the challenge of controlling how collaborators actually interact with specific branches and tags in your repositories. That's exactly where repository rule sets are coming into play. Repository rule sets provide a powerful way to control how users can interact with certain branches, as well as tags in that repository. By creating rule sets, you can define a named list of rules that govern various actions, such as pushing commits, deleting, renaming tags, and probably more. Rule sets work alongside branch protection, as well as tag protection rules, allowing you to have fine-grained control over your repository's behavior. But what are repository rule sets actually about? A rule set is a named list of rules that gets applied to a repository. You can create rule sets to control things like who can push commits to a certain branch, or who can delete or maybe rename a tag. For example, you could set up a rule set for your repository's feature branch that requires signed commits and blocks force pushes for all users except repository administrators. Also, you might remember that there's a limit of 75 rule sets per repository. Rule sets work alongside any branch protection rules and tag protection rules within a repository. Many of those rules you can define within rule sets are similar to protection rules, and you can start using rule sets without overriding any of your already existing protection rules. Additionally, you can import existing tag protection rules into your repository rule sets. This allows you to implement the same tag protections you currently have in place for your repository. Now, rule sets have a few following advantages over just the branch and tag protection rules that you might already use today. Unlike protection rules, multiple rule sets can apply at the same time, so you can be confident that every rule targeting a branch or targeting a tag in your repository will now get evaluated when someone interacts with that branch or with the tag. Rule sets also have a certain status, so you can easily manage which rule sets are active in a repository without needing to delete those rule sets. Next, anyone with read access to a repository can immediately view the active rule sets for that repository. This actually means that a developer can understand why they have hit a rule, or maybe an auditor can check the security constraints for that repository without even requiring admin permission access to that repository. And then also keep in mind that a rule set doesn't have a priority. Instead, if you have multiple rule sets targeting the same branch or tag in a repository, the rules in each of these rule sets are getting aggregated. If the same rule is defined in different ways across the aggregated rule sets, the most restrictive version of the rule is getting applied. The last security capability I want to highlight in this section is the power of reporting and logging. Your organization's log records actions taken by organization members. The logging is available to organization owners and records information about actions that affect the overall organization, including the repository in which the action was performed, the user that performed the action, obviously the action that was performed as well, but then also which country or region in which the action took place, and then also the date and time of that given action. You can access the audit log through the github.com website using GitHub Enterprise Server on-premises, or even available within GitHub Advanced Enterprise Private Cloud Solution, allowing you to review actions from the past 90 days. Instead of using the portal interface, administrators could also rely on REST API or using the GraphQL API specifically. GraphQL gives you the additional benefit of allowing you to retrieve information up to 120 days. With that, we covered several of the GitHub security best practices for your organization and your repos. We touched on different capabilities, so I think it's time to switch to my demo environment and walk you through several of the discussed capabilities. In this specific demonstration, I'm going to show you what it takes to define collaborators and allocating permissions. I'm going to show you how you specify open source security, contribution, and overall README files. And then last, I'm going to close with walking you through the configuration of the rule set. So for this demo sequence, I want to highlight 3, maybe 4 different things. The first one is obviously, I guess, pretty obvious, the difference between public and private repos, talking about how to define permissions or collaborators, showing you the configuration of rule sets, and then closing with touching on a few other secret or security capabilities. So the first part, public and private repos. Again, this seems pretty straightforward, but I'm inside my GitHub account. I go into repositories and I navigate to new, where it's going to ask me who's the owner of the repo, where I can select myself. But if you're part of an enterprise with multiple organizations, you can actually define the organization as well. My repository name is GH-500 live demo, because I have a few other GH-500 repos that I'll share with you later. A description, which I think is always beneficial, not really a security capability, but nevertheless quite relevant. Live demo repo for GH-500. And from here, security feature number 1 is highlighting public or private. Where again, public means the whole world, everyone gets access to the repository, and private means you need to specifically invite the users and then also defining the permissions. I'll move on from here since our overall topic is best practices. Yes, security focused, but I'm going to highlight a few other GitHub recommended best practices. Depending a bit what you're going to store in your repo, I would immediately highlight to use a git ignore file. While again, not specifically built as a security feature, it actually allows you to remove or exclude, might be better, exclude certain files, folders, characteristics out of your repository source control on your local machine to not be moved into that source control scenario. I'm sort of, I would say, more familiar with .NET. So in this case, I'm not going to build an actual app in this example. I'm just going to flag .NET, and then maybe I can highlight some of that in the actual repo file later on. Also important, since we're talking about a public repo over here, the recommendation is to add an open source license. I don't have the time, and it's a bit off topic, to walk you through all the different options, but just know that it is quite expected in a public repo that you highlight some of that licensing to just clarify to the rest of the world how they can reuse, or maybe not reuse, but then I don't see a lot of sense in making it public, and reusing your code base. From here, I just confirm, and we're going to create our repo. So since I talked about that git ignore, and again, this is an example for .NET. So what it means is that by design, it's going to exclude the .NET debugging folder and the build release bin object logging, because that's typically the compiled version of the app, and that's not really what we need or want to store inside the repo itself. So those are getting created on our local development workstation, but they will never synchronize back to the repos. And then as you can see, there's a lot more options here. You can add your own folders into it, or explicitly defining files, like for example, the App settings, development JSON file, I think is also part of that configuration. Few other things we can add here is, for example, emphasizing the security concept, like how do we as the repo owner creating this public repo, how do we deal with security? The way GitHub provides this is creating a new file, and you can call this file just security or security.md for Markdown. And even without adding any details, but I can actually point to a reference site. Give me a second here, where inside the GitHub docs, there is a sample file. So I'm going to github.com and then opening the GitHub organization, and then inside looking for the security file. Now this is a list, it's just a sample repo where you can see here that we have security details. Now how does this work? Once you create your security file or the security MD file, the idea is that you're going to add security guidelines for anyone bumping or using your repository. So I could make this a little bit easy for myself in this demo example and just grabbing everything from here. I move it into my file, and obviously it's not just copy pasting. You should actually look a little bit more into this, but I hope the example makes sense for you. We're going to commit the changes. And if we go back to the root of the repo, we now have this little flag here on the side. By the way, the same for my open source license. So this is a quick, easy view how GitHub allows you and technically your repo collaborators to immediately identify what is your security policy like. That's also the same for the README file, the code of conduct file, and the contributing file. But again, they're not specifically security related, but the concept is exactly the same. Now we do have our repo, so we can move into settings and from there defining the access permissions. So there's a few different sections here. We have collaborators and moderation options. Now you might go like, what's the point in having collaborators in a public repo? Well, since I created the repo, I'm the owner, and that means that now all of a sudden I'm responsible for watching over pull requests, issues, maybe discussions, and anything else that we have on the GitHub platform, where maybe, although it's public, I want to allocate one of my peers, one of my colleagues, to help me with that ownership/administrative activity. So that's what you can define here. The way it works is you can scroll through your full GitHub address book. In this case, again, since it's a public repo, it's going to show me pretty much everyone available as a GitHub public account. If you have a GitHub Enterprise and you create a private repo, then it's only showing the list of approved GitHub users within your enterprise environment. Out of the moderation options, you can identify a few more, I would say, lower level, more granular permission scenarios to, for example, here limit only existing users where new users won't have any permissions to do whatsoever, limiting prior contributions. So this could be in some sort of a transformation where you might have had some contributors and then at some point you might decide, or they might decide, to leave the project, and that means you should remove some of their permissions. And then the same for the repository collaborators. So those are users that are not collaborators, but if they're not collaborators, that's how I have to say it, they won't be able to interact with the repo. So a bit more granular options. And then technically the same for code reviewing, where, as you can see here, there is a section or a setting, limit to users explicitly granted read or higher access, more than just read, which could be rewrite, approve, decline in your pull request. Same concept again for private repos, but obviously giving you quite more permissions. From here, I'm going to jump into the actual rule set capabilities. So what that means is if I go into my repo, I'm going to clone this to my local machine. I create a new empty folder. I'm going to call this the GH-500 live demo. Without the space, obviously. And then I'm doing a git clone, and I'm adding the link that we just grabbed. Now I could simplify this a bit more. If I started with git clone, providing the link, and then actually after the link, providing GH500 live demo, it would automatically create it. Cloning all the details, and then from here, I'm going to open up my Visual Studio Code. And make it a little bit bigger. There we go. Now, what we have from here, one of the first things is obviously since it's a GitHub repo, we have source control baked in. So this little extension here on top is integration with source control. Now, I didn't make any changes yet, but you can see the history of the repo actions. We initialized the commit, which means the first step in creating the repo, and then also adding the security file. Now from here, again, zooming in on some of the security best practices is creating a new branch. The way to do this, there's a couple of different options. The easiest one in VS Code is selecting your existing main branch, which we have down below, and we're going to create a new branch. The assumption here is obviously that you do have the permission to actually create a branch. I'm going to call this the PE tender branch, but this could be a feature branch, this could be an issue branch, a bug fixing branch, so just using some of the default operations. Now the benefit of using different branches is that I'm not touching main, and later on when we talk about the rule sets, you're going to see what I'm trying to simulate here. So I created a new branch, and let's make some code updates. I'm going to do this super easy. I'm not even adding any specific code into it, but in the end, it's just code updates. So I'm going to add the policy, added more security policy information here, email securitypol at petender.com. I'm going to save my changes. I'm going to commit my changes, added security policies, committing locally, and then from here publishing the branch into my actual GitHub repo. This shouldn't take too long, so when I move back to my repo, you can now see that it's immediately recognizing the branch. Typically from here, we would go through the pull request and then merge it. So I'm going to compare the existing main with the new branch, added a description here. I'm going to create my pull request, and the benefit here obviously is that I'm the owner, so I'm going to go through the review, everything looks good, and I'm going to merge, and we completed the first part of our DevOps process. Why is all this important? Because now obviously we want to lock it down. And yes, it's just me working on this project, working in this repo, but it would be about the same if you have multiple DevOps users. So what we can do is now fine-tuning the security, integrating some baseline security capabilities. I navigate to the Settings tab, and I go into the tags option here. Now you can see tagging is sort of being deprecated. Now you can still use it, but the recommendation is to no longer use it, and here migrate to a tag rule set using August 30th, which is in this case about 6 months back. So what we can do is go to rule sets and creating tag rules. You can do the same straight going into rules and then obviously selecting rule sets, but I know that quite a lot of customers are familiar with the traditional tagging and just wanted to emphasize that. Same for the branches and the branch protection rules. They're now also recommended being moved into rule sets. So we're going to create a new rule set, and I'm going to call this the demo rule set, super original. First experiment here is disabling, which means we're going to create the policies, we're going to define all the settings, but they're not getting used yet. Second part is obviously why not enabling it. So I'm going to activate it right now. There's a bypass option, which I'm not really going to show you how it works, but the idea is that you can define all those rules, blocking access, for example, blocking specific tasks against the branches. And then if you fit in that bypass list based on any of these, so you can use keys, you can interact with your pipelines in GitHub Actions or even Azure Pipelines if you have that integration, or if you're the repo admin, those are some of the permission exceptions to bypass the rules. What we need to define here is a target. So what is the target? It means which of your branches are linked to this rule set. So we're going to add a target, and I'm actually recommending to use 2 different layers. What I mean by that is include the tagging, but then also, for example, searching based on a pattern. From there, you have a whole set of tag rules restricting creations, updates, linear history, requiring signed commits, and so many other options. From here, you would confirm, you would create, and then everything is working fine. Now, tagging is not the only option. So what we can do here is go back to the rule sets, where we can also create a branch rule set. The concept is identical. It's just the difference between using the older tagging feature on a branch or now using specific branch. Since we created a branch, I'm going to create a new one, and I'm going to call this the branch rule set. Bypass, same concept as before, pretty easy. And now I'm going to add a target. What I'm typically doing here in my production environments is again using the 2 different allocations, including the default branch and including a pattern. Why including both? Because the default branch, the assumption is that your main branch is the default, but inside the branches options, you can actually move the default branch to another branch. So that's where I like, in this case, let's say we're protecting main, which is I guess the best practice to make sure that not all code operations, all PRs are going straight into main. What that means is we would include the default branch, but then also including the pattern where I'm going to add main, and that's like an additional level of protection. Same set of restrictions that we can apply here. So we could add restrict creations. Nobody can create more branches. Nobody could update, but that wouldn't make a lot of sense. But in this case, it's perfectly fine because, again, we want to protect our main. And that means that the pull request is the mechanism to actually create those updates. There's a few more options here, but I might come back to these because some of them include like code scanning. So just keep that in mind that it's pretty powerful. I'm going to create and just going to make sure, there we go. I also need to define it as active. So now I can switch back to my Visual Studio Code, and I'm going to create some more updates, adding more information in the security details. I'm going to save it. Source control kicks in. I commit local. I need a commit message. Let me close this. More policy information, committing, synchronizing. And as you can see, this is all working fine. Where now, if I switch back to my main branch, I'm first going to synchronize my updates from before. Where now, if I make update to the security policy in main, saving it again, committing local. I learned from my previous mistake to add a little policy update description as a commit message. And then synchronizing. Obviously, it's now going to block me like, hey, you cannot do this. If I look into the actual Git log, you can see that a little bit where it's providing you more details. Like this is the reason why the sync is not working, repository rule violation, and then from there, it's actually providing that link to the rule base. It's going to show you which rule base is relevant, and from there, you can read out the information. That's pretty much it on rule sets. So in short, you define the rules, you can do branch rules, you can do tagging rules. The best practice, define default protection and pattern as the naming for the branches. And then obviously, depending on your use case, you pick any of the different branch rule settings, and you can see that without doing much, it's immediately applicable. Last little piece in this demo, because I've been talking, I guess, for about 15-20 minutes now, is the secret variables. Again, this seems one of those obvious options, but every now and then in my GitHub classes or DevOps classes, I'm still surprised that a lot of customers are not always using this. So what that means is you can create variables for different features within GitHub. Actions refers to using secrets in action workflow pipelines. Code spaces is the online VS Code in the browser, where you can again reuse some of the secrets. And then the Dependabot, I'll talk about later on, but it's the vulnerability scanning. So what we can do here is move into our actions settings. And the big difference is that if I create a traditional variable, let's say I'm going to create one for this repo, the name is environment name, and the value is development. At any moment in time, I can go in and I can see the actual value. If I do this on the secret side, I'm going to call this my secret variable. And my secret variable is password. I'm going to add my secret. You can now see that it's not viewable. Next to that, if I open up this one here and editing, it's immediately wiping the actual secret, just out of protection, and then obviously also storing it in an encrypted way. Now, quite important just to wrap this up, this last piece is just GitHub security. It's not related to the GitHub Advanced Security. And that's, I would say, my little segue back to the presentation, where I'm going to wrap up this module and then jumping into specifics of GitHub Advanced Security itself. The goal of this module was to help you understand how to protect your GitHub organization from security risks and what to do if there is a sensitive data exposure. You learned how to create documentation to outline security guidelines and providing useful information to any collaborator. Next, you learned how to set permissions and rules and how to manage repository rule sets. We also covered how to respond to sensitive data exposure, and then last, I showed you how to export audit log records and Git events. You reviewed GitHub's basic security tools, including the documents and settings available to secure your GitHub organization when working with collaborators. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn at aka.ms/learn. I would like to thank you for having been here with me for this GitHub Security Best Practices session. There's a lot more to talk through, so why not follow me to the next module, where I'm going to talk about Dependabot vulnerability scanning. See you back in a bit.